And we're back, opening the parentheses to another LispNYC talk. My name is Arthur Smiles. I'm the host. Welcome aboard. I say let's get started. Okay, so let me introduce the speaker. Okay. To, by the way, I just want to say that I first of all, I want to say I'm excited about learning about Gerbil Scheme because it happens to run on one of my favorite schemes, Gambit Scheme, which I use quite a bit, but I never really, even though I heard about Gerbil, I'm really excited to get to learn about it. So we have someone to talk about it. Dimitris Vyzovitis, Vizo.
Yes, that's correct.
Yes. Okay. He is an old school hacker and engineer. He's interested in PDB systems, network protocols, and programming languages. He's a software engineer, and he also likes to hack Gerbil on the side. So with that, let's welcome Vizo. And we're on. I'm going to show a screen. There we go.
Hello, guys. First of all, I would like to apologize for not being visible in video because it's new computer and Linux problems. Eventually, I hope to get it working, but we didn't start early enough to figure this out. So I would like to say hello. I'm Vizo, and I'm gonna talk to you about Gerbil by dissecting or vivisecting, actually, because it's a live program. Like a real Gerbil program. Okay, so this is what I call gerbil anatomy. First of all, let's talk a little bit about gerbil itself. So, what is gerbil? So, as like the blurb says, it's a pretty postmodern meta dialect of Scheme. So, here are a couple of URLs where you can find out more about it. So, the first URL is our main site. It hosts the gerbil documentation. And below is where you can get the source code on GitHub. We have distributions, for Docker already made containers that we use a lot. We are in some of the package archives, for example, in arts, we are in the main arts, and we do produce debs. We can produce debs using Docker, but we should start, actually, I guess we should start publishing this when we make new releases. So, but fear not, it's pretty easy to set up from source if you follow the instructions. And with that, let's start talking about the features. So, what is that makes Gerbil interesting? First of all, we have a very state-of-the-art macro and module system. So it was inspired by Racket because before Gerbil, I used to use Racket a lot. And in fact, the very first version of Gerbil, like some 15 years ago, was written as a custom language in Racket. But eventually there were a few things that made me fed up and made me switch to Gambit and actually make a proper language on top. And the most important one is actually generating binaries and distributing those binaries. But before we get to that, the micro module system is so good that we have really unparalleled meta programming facilities. We can do a lot of magic that very few other languages can approach. I mean, Racket is comparable. It can do many of the things that Gerbil can do. But as I said, there are things that we can do that Racket cannot do. So we have all the niceties expected from a modern language. So we have great concurrency primitives. We have Gambit to thank for this because it has great concurrency support. But on top, we have a lot of libraries. We have actor support and things like that. We have a nice object system, structs, classes, mix scenes. Structs have fields, classes have slots in the common list style. We have generics, and all this come with a really extensive standard library to which we're continually adding things. And we also have interesting tooling. We have a package manager, we have a test runner. We're going to show some of these on the demo. We have source tagging, so you can work on Emacs and you can metadot your way around. And last but not least, this is one of my favorite features. We can actually produce fully static binaries, and we're gonna show this off. And I don't know many other schemes, or in fact, I don't know any. Maybe someone can correct me. Any other schemes or libs that can actually do that. So this is a very big static, feature. Obviously, Gambit can do it because we are based on Gambit. And this is, like the gives us to the ethos of Gerbil. So, like Gerbil is intended to be a very pragmatic modern scheme implementation. I I personally don't care about solving theoretical problems, like language design. I want the language that actually works. It's practical. You can build system. You can you can zip a binary in your servers and have it running. So we run on top of Gambit, and we're very proud to be running on top of Gambit. So we retain, expose all the power of Gambit. We don't hide it. So you're gonna guess you need Gambit in order to use Gerbil. And the bootstrap is actually very clean because Gerbil is written in itself. The bootstrap is actually readable Gambit source. So even though it gets regenerated by recompiling the prelude and stuff, it's still readable Gambit source. Okay, with that, let's talk about a real Gerbil program. So I believe that's the best way to present the language by showing a program that is written in the language. Okay, so you can't really talk too much about something in void. You need to have some basis. So like I wrote a password manager, and because one, I think that all the password managers out there suck in one way or another. Okay, so I just tried my own take, but also because it's a practical, non-trivial program that can be pretty didactic. We can solve several features of Gerbil, and you can call this in the context of a program that works. So the source code for the program itself is on GitHub. There are installation instructions. If you have Gerbil installed, you can install it using GXPKG, which is the package manager. And if you don't, but you have Docker, you can actually build it. You can build a fully static binary by using the make file. Okay, with that, I'm gonna switch to Emacs. Okay, so here we are. Right, this is okay. Let me do a little bit of cleanup because I want to do a demo here. Can you see my screen fine? Can you read the stuff I'm typing on Emacs, or
We're
should
good.
I? We're good. Okay, excellent. Okay, so here you can see, like the structure of the program itself. So like we have it's a directory, the top directory. It has a Gerbil package that basically contains meta information for the expander. Here we just say that everything goes into the package of Viso. What this means is that the symbols that are actually exist in the runtime, they're going to be prefixed by Viso and the directory structure. So, like if we see the modules in here, I'm going to get back to it and explain more about what's happening here. But this means that, like they're the real symbols. Okay, let me get a scheme interpreter running. And let me, actually, I'm going to do this a little later. Basically, the symbols, like are going to be prefixed by Viso, Passman, and the module where everything is. So in here, after the Gerbil .package, what we have is control meta x. All right, it was meta x. Control shift. No. What was the font buffer increase font thing again?
Control X, Control Plus.
Ah, yes. I keep forgetting. No. There we go. Okay, so this is how we actually build this thing, and I'm gonna build it right here. So basically, we can invoke the build script.
So
This is
yeah, before you continue, so basically the idea is that you can specify which file is where the main function is, right? That's what exe is.
yes, yes,
And
yes.
bin is just the name of the name of the resulting binary you want.
Yes. So in here, basically in the dev build script, we give it a specification for the build, which basically just includes the modules that you want to build with some specification here. These are plain modules that we're building, and this is an executable file, which is this passman main command, and this is like the binary that's it's gonna build. So we just build it, and we can run it. Okay. And the first thing to ask is, what is the damn binary? Because I don't see it here, right? So You can obviously you can change this in your build script. By default, this goes into home visual, basically in your Gerbil home, your local Gerbil path, which is within your home directory Gerbil bin, and this is where it went.
Mm-hmm.
Okay. All right. So this binary just runs. Like it says missing command. We can do something like help. Like, and it's going to tell us what kind of commands it support, and we're going to go through these commands. And after we give a small demo of how the program works, we're going to go through the code and look at what is happening there. But let's talk a little bit about this binary a bit more. So by default, when you do an exe and you build a binary, it builds what we call a dynamic binary. So this dynamic binary compiles very fast, and it has dynamic dependencies on both your Gerbil environment and the modules that you're using. So if we do an LDD on that, you'll see that it has several dependencies. So obviously lib Gambit, because I compile with my Gambit assert library, and all the usual stuff. Okay, so where are the static binaries we're talking about? You can build it, directly if you want by specifying static exe instead of exe. But this requires you to also have support for everything being static if you want to build a full static binary. The preferred way to do that is actually to use Docker, because that means you can get the Alpine Linux container, Gerbil built on Alpine, which is best practices, everything static. And basically then you invoke this inside the container. You just pass it, like the C compiler ops or be static. Then for the linker, you say, okay, do static, and basically include those things. And also what's important is that this Docker container is specialized to already have, Gerbil built with full static support. So here we can do just make and invoke the make file. Okay. It didn't download the Docker container because I tested it earlier, so it's downloaded. I would have to Docker RMI, so it might take a little bit of time for you to fetch the Docker container. But once this is done, it goes ahead and compiles. So, okay, so sorry about this spewing out, libcrypto, we have OpenSSL 3.0 deprecation. So this is on my to-do list to fix, because these are getting annoying. SSL, OpenSSL suddenly decided to start deprecating everything. So,
hey, password managers are hard. So kudos to you for making one.
Yeah. Okay. So, this compile, it takes a little while to compile with for a static binary, because it has to compile all the sources together. There is the tree shaker involved, a lot of optimizations, but it's not going to take that long. It takes like 30 seconds. It's there. And if we look here, we have a passman.bin, and if we do LDD on passman/bin, we see that it's not a dynamic executable. And if we run it, it just works. Okay. The other interesting thing is the size. So this is 22 megabytes, but we can strip it. And now it becomes 11 megabytes, and amazingly, it still works. Okay, so this is the first introduction to Gerbil. This is how we actually package software. And let's take a very quick look into main before actually start exploring the commands, because this is what we built from. Okay, so main basically, okay, this actually I can remove, that was earlier in development. So anyway, so the main uses our library getopt. So we have a nice getopt library. Okay, so we can even jump to the definition. We're gonna do this later a lot more. Okay, so this defines a DSL, that allows us to write simple commands. There is a lot of code, tagging really helps. So basically, what is getopt? You give it a help that says this is what it is, and you give it a bunch of commands and obviously options. And the commands are defined in here. Okay, so these are some common options for everything, like the path option to specify where the vault is. Okay, the passphrase, if you want to pass it in the command line for integration to other tools and you don't want to take it from the terminal. The input, if you want to pass it input instead of reading it for std in. This is the entry key. This is used in some things. Okay, and basically here we use the getOp DSL. So create commands as a command. You give it a symbol, you give it the options that it takes, and this is what creates a new vault. And down here, which is where the driver is. So you see we have a nice try-catch construct. Okay, we just say getOpt parse, like with our getOpt object, and the args we got in main. So this is the invocation of main, which take the arguments. Okay, and once we parse this, it returns us basically the command that we have actually selected if the getOpt object has subcommands, and the hash table that contains options. Okay, then we start working through this hash table using like one of the cutest macros around, which is called let hash. And what this does, it basically introduces a local binding for unresolved symbols effectively. Basically, if you do .he, it translates to hash ref from your hash of the symbol x. Like if you do $x, basically it does a hash get which returns false if it doesn't exist. And if you just want to refer, do an escape, you do $x. So this is an instructive macro. I'm going to get back to it because this is one of the cute macros. Like one of my Gerbil conspirators, like Ober, asked me, hey, can we do something like that? And that was really early in Gerbil's development. And I was like, that sounds like a good idea. Sure, we can do it. And we end up using it all the time because it's really, really nice. Okay, so you can see here that we say the create command basically calls a create vault, which is basically takes this path. This is how we take it from the hash, and basically it passes the passphrase. Okay, so let's create a vault. Right, I think I have my test vault already. Yes, let's delete it. So let's say pass1. Let's use actually the. Okay, I'm going to use this because it's less stuff to type. Create, and we want the path to be tmp for vault. So first question you might want to ask is here, what is this vault we're talking about? So here is the passman model. Basically it maintains an encrypted file, which we call the vault, which contains sensitive information. The file contains, a list of records, which are key value pairs. Basically, the key is a symbol, the value can be anything, and the only key required is basically the key, which is how you identify uniqueness of entries. Okay, does this make sense to you? So basically, you see, passman is a little bit more than a password manager. It's a generalized, sensitive information vault manager. But I use it for passwords, and passphrases and things like that. But you can obviously use it for other things as well. So let's create this one, and this asks us for the passphrase, and Emacs intercepts this and gives it on my mini buff. So I'm going to put a very, very strong passphrase of 1, 2, 3. So we'll start it again.
Yeah, and I would have never guessed that, by the way.
Which one?
The password. I mean, that's a really strong password. I would never have guessed that.
The 1, 2, 3. Yes, this is for demos. I don't want to be typing all the time.
That's all my passwords going forward. No one's gonna figure that out. Anyway.
Yeah. Okay. Yeah. Well, the thing is that the key derivation function, we're gonna look at it later. It's a script, so good luck cracking it. But it's very, very simple. Okay. So you see, it created a file that is like 11 bytes long, and if we do a file on that, we'll see. It's some garbage. I mean, we can type it as well. You can cut it, and you see it's like a bunch of bytes. Okay, so now that we have a vault, let's see if we can actually access it. So we have a dump command which can dump the contents of the vault. Okay, so it gives you a warning. Do you really want to do it, because it's not a good practice, but it's very useful if you want to dump the vault in order to transfer it to something else.
Yeah.
So, and it asks us for a passphrase, and we see that it's empty. Okay, so let's add something to the vault. Okay. So we're going to use the help command. So we need to pass this so that it doesn't conflict with my default one. And we need to give it a key on how we're gonna call it caller entry. Okay, this is the primary key of, if you think of it as a database, that's the primary key of the key value command. So again, I'm gonna start passing it. And here's the thing: if you're adding something, there are two modes. One is to do it in plain text, in which case it is some key and some value foo bar. Okay, comment echoes buzz cooks. Okay, and we just hit Control D, and this added, like a render. So we can also do it using JSON, which is very useful. I mean, typing these key values is very good if you're doing it yourself in the command line. But if you want to use a front-end program that actually uses passman, then you can just pass it as JSON. And if we do, the dump again, I'm going to pass does y so that it doesn't ask us. And you can see this is, like the passphrase. And obviously, we can also, export it as JSON as well.
Cool.
Okay. So once we have added entries, we can do all the basic CRUD stuff. So, for example, we can update, which means we can add update. What was the name? I forget. Test foo. Okay. So we can say, what happened here? Oh, yes. I tried to use my default pass. Sorry. My default vault. I don't want to do that.
I'm going to just restart that.
Okay, it started apparently.
And I think we have a good connection. Okay, we're back. Okay. Sorry for the interruption. Continue.
Okay, so what I was saying is that we can actually also search the values, for in our key value store. And in this case, with a regular expression, and here I'm just searching for example. Okay, and it finds our key. But if we search for something, that really doesn't exist, so it's not going to find anything, as we can see. Okay, so, and we can also obviously delete entries, and do to complete the CRUD. I don't want to delete it though. And there is one more little thing that is very, very useful. So basically that's one generate. Okay, and this is what is very specific to password manager. So because all these sites have these stupid rules, you have to include one lowercase, one uppercase, one special character, and they're not even consistent. Everybody is asking for something different. So I made something that works for all common cases. So at least one lowercase, at least one uppercase, at least one digit, at least one special character, and a default length of 12. And we can ask it to generate a password for us, and this is a pretty good password. Okay, good luck cracking this.
Yeah, exactly.
Yeah. So this pretty much, concludes the demo of how to use the password command. So this is what the password manager does. It's it has everything you need from your password manager, and it's designed to be a tool that is used by other tools. So I would love to have a front end, but so far I'm using it in the command line in my laptop. But I would like to have a front end that is actually easily integrated with the graphical desktop environment. And I would love to have this working on Android, but I haven't gotten there yet. So help is always welcome. Okay, so any questions so far?
Looks pretty good on the password manager front. I'm curious to see the back part. The back.
Yes, now we're gonna get the cool part, which is the actual code. Okay, let me make sure we have tags for navigation inside Passman. All right, so here we are. Let's start looking at the code. Okay.
GX package, that's part of Gerbil?
Yes. GX is the package manager that comes with Gerbil.
I see. Okay.
Okay, so let's get back to main. Okay, so here is all the dispatch to all the commands that we have. Yeah, let's start with the simplest one. Let's start with generate password. Okay, this is generate password. Like I love tags. Like I know that many people, like, prefer different completions and stuff. I just use MX tags and love it. Okay, so this is an interesting little function. So here it defines, like the string sources for all the classes of characters. So
Mm-hmm.
lowercase, uppercase, digit, special, and all of them, like
Mm-hmm.
are the concatenation of the strings. Okay, and we have a little function that says get password cars. Okay, that basically gets characters from one of these sources and how many you want.
Mm-hmm.
Okay, so this is the string, and basically we use a for loop. Yes, we have for loops. Okay, for I in range count. So this is self-evident in what it does, right? So it generates I starting from 0,
Mm-hmm.
like up until count -1, and we're
Mm-hmm.
just setting, like in the string that we're going to be the result, a
Yeah.
random integer picked from the source.
Mm-hmm.
Okay, so what basically this does in generate password, so we make the password that we're going to return with make string, we have a cursor on it, and we define a little macro that basically calls get password. Okay,
Mm-hmm.
it copies into, like the current password at the cursor, and then advances the cursor. Look, mutations. Yes, mostly functional programming. I love my mutations. There's nothing wrong with local mutations. The only time you have to be wary of mutations if it's a global or if there are threats involved. So
Yeah.
it's neither a global nor
Good
threats
point.
involved. Yeah, we're just being pragmatic. Why not mutate? What's with all, like the demand to write everything functionally? That
Mm-hmm.
makes no sense. Like this code is so much clearer to read than a purely functional solution. So basically, what we do is that we add as many password cars from each class we specify. Okay, and then we fill the rest by randomly selecting from all the cars, and in the end we sample this.
Mm-hmm.
Okay, so convert it to a vector, we call a library function, which is this one,
Mm-hmm.
vector sample. So it's an unbiased sample. Okay, and then we just return this string. So we convert the vector back to string. So it's as simple as it gets, but I would say that this is pretty clean code. Get to know.
Very. I have to say, I think I think I have a thing or two to learn from your code about, because sometimes my code gets a little messy on the list thing, and it's sort of like I think I should be able to do this better. I just don't know how. So I'm gonna study this for a little bit, some style guidelines to think about, like,
Yeah, well,
because
the
I do
only style
like.
guide,
Right,
the
you
only
should, right?
style, yes, the only style consideration I have is like keep it simple, stupid. Don't try to be too
Yeah.
smart. And if you don't repeat yourself, make a macro if you find yourself doing the same thing many times.
Yeah. Sounds good.
Okay, let's go back to main, and like let's look at some more complicated commands. So let's start with the creation of a vault. Okay, so you see that we have it in two places. One is in the command module, which is where the commands are implemented, and there is an underlying vault module where the vault is implemented. So, okay, first we check if the vault already exists. We don't want to override an existing vault because that could be potentially a tragedy if you lose all your sensitive information. Okay, and there we get a new passphrase. Okay, so this is local; it's not exported. And it's right here. We just do it twice by calling the get passphrase function,
Mm-hmm.
which calls like a library function, which just got added. And this library function is designed to work in both inside Emacs and in terminals. Okay, so basically it displays the prompt, and if it sees that it has a dump terminal, which is what Emacs does with everything, like in the default terminal, then like it does some magic to turn echo off and just reads it. Otherwise, I'm using some code that Mark Philly actually wrote, who is the author of Gambit, and posted
Yeah.
it on Gitter, and it works well on terminals. So it works both on terminals and it's inside Emacs. Because you see, the thing is like Mark's code doesn't work inside Emacs,
Mm-hmm.
and my code, like doesn't quite work inside terminals. So you have to use both.
Mm-hmm. Makes
Okay,
sense.
so we get the passphrase twice. Obviously it's important that we don't echo this passphrase. That's the reason behind this library function, because this is a common operation and it's very easy to get it wrong. And obviously, if the passphrases don't match, it's an error. Okay, so if we go back to create vault right here. So first of all, we create the directory of the path. This is like doing make dir p does p. This create directory star, and then we call the other create vault, which is inside the vault. This is the vault itself. The vault itself, which is basically designed to be a reusable module. So if you want to use the passbands functionality programmatically from another Gerbil program, you can. You can just import this module. Okay. So here what it does is it makes a new vault object and it calls on write vault. Okay. Make vault is implicit from the struct definition. So the vault is a struct that encapsulates the path and the pass, and there is a list, the list of entries that we have. The interesting function here is write vault. Okay, so this is an encrypted vault. So a couple of things. We're going to do this write atomically, right? We don't want to overwrite an existing vault, like we'll leave it incomplete or anything. Okay, so we do a small bunch of things. So first of all, we create a temporary, we're going to write the encrypted blob. And also we take a backup, of the current vault before overwriting it. Okay, so we check if the TMP file exists, then we just nuke it, we don't need it. We open an output port that collects everything written to it, as a byte vector. We put a magic in front. This magic is just a string. It's nothing special. It's there to make sure that after you've decrypted a vault, you actually have a valid vault. It needs to be there. Okay, and then it just writes the vault entries, as JSON. Okay, again a for loop, and yeah, we have JSON. We have a pretty good library for doing stuff with JSON. I can't imagine, I can't imagine not having JSON support. How can people live without this? The language could be incomplete without it. Okay, we can look at some more code here, some more details. This is just a parser. It's fairly fast, and it does all everything you need to do. Okay, so after we write that, so we get our plain text, which is the output U8 vector from the buffer. We use our libcrypto bindings, which is basically the OpenSSL libcrypto. We make a cipher. So make cipher. This uses AAS, 256 at counter feedback mode. Nothing special to see there. Okay, we encrypt it, and by using a Q derivation function, so which is just a script with this salt and default parameters. All right, let's go back. Then we call with output file, on the TMP with permission 0600. I mean, even if it's encrypted, you still don't want other people stealing it, right? You don't want to let them start cracking it. Okay, and we just write this Q8 vector. If the old file exists, we delete it. If the existing vault path, it's not a new vault, it already exists, we move the current vault to the .old, and then we rename, atomically rename the blob that we wrote, into the existing vault. So basically, this is, simple code. It's straightforward, but you have to be careful because there are things with what happens if the power goes off in between, right? So this is written in such a way so that you cannot lose your vault under any circumstances. Okay, does this make sense?
Yeah.
Okay, and once we've written the vault, we return it. So if you're using it in the command, we don't do anything with what we return. But if you're using it programmatically, you might want to do some stuff with your vault. Okay, so let's go back to main and let's see how we actually add stuff to the vault. Okay, again, what we're passing here are the parameters, so which is the key that we're adding, the path to the vault, the passphrase, like if we specified in the command line, the input if we don't want to read from the current input port, but instead pass the input directly, and the JSON flag. Okay, so if we just go there, okay, again, we check whether it exists, we get the passphrase, and then we called the vault read function. Okay, so that's still in the vault. So I had a little bit of renaming this, and like that's the open vault, which basically makes a vault object and reads a vault into it. This is the inverse operation of the write. Okay, we just make we just read directly into memory the whole file as a byte string, which is the ciphertext. We make the cipher, we decrypt it. Okay, we check the magic right here by reading the first line, and then we just read ND.json from it, and that's all there is to it. And look,
Okay,
here's a schema loop.
1 minute?
Yes, of course,
Actually,
of course.
We got a question on the chat. I want to read that and get your reaction. Rather than demoing the mechanics, it would be a good understanding to understand the difference between Gerbil has with Gambit and the scheme standard.
Oh, yes. Okay. I think this is a pretty big topic. We can talk about it right now, or we can talk about it a little bit later after I'm done with reading the vault.
Yeah,
actually, I'll talk about it in 5 minutes. So, okay. So you see here, this is a standard scheme loop. Like we use for loops, we use standard scheme loops. We have for/fold. Like that's pragmatic. Whatever works better and makes for the best code. So like in this case, because we want to check for the off object, we just do it with a common loop. We could also do for/fold. Okay, so I don't think there is anything special, like in the read vault. Okay, now let's get back to the question. Okay, so first of all, Gerbil is a meta dialect of scheme. Okay, it's scheme in scheme. It's written itself in its own dialect. So it has a bootstrap, which is source code compiled from itself. It was painstakingly bootstrapped with like a very primitive interpreter I wrote like some 10 years ago. Okay, but once I did that, I had a bootstrap, which is a bunch of code that compiles by Gambit and standard Gambit code. So what's the relationship to Gambit? Well, Gambit is the underlying engine for Gerbil. Gerbil offers a lot of stuff. Like it's not just the language. We have like the library, the tools, and everything. But nothing is possible without Gambit. Like I love Gambit. I think it's the best scheme implementation.
Awesome.
Yes, so we are actually, like enhancing Gambit, and at any given time, you can just use Gambit code directly. No, and we do it in a lot of places. So Gambit is not hiding underneath. When we are compiling a file, if you want, we can go through the compilation process a little later. We can look at the compiler a little bit. But basically, what it happens is that you give it, Gerbil source, it expands it through the Gerbil micro expander, writes, like a scheme file, which is Gambit source code, expanded, and then it compiles through the Gambit toolchain. So this might change a little bit in the not so distant future, because we just started discussing on Gitter some brilliant work that Drew C has done. It's another Gerbil conspirator, where we basically start directly embedding Gambit as a Git sub module inside Gerbil. And this is going to simplify a lot of things, but it's a lot of work. I mean, I don't know, maybe in a few months it's going to be ready, and we're not going to need to generate an intermediate file, and with all the advantages that come with that. Okay, now.
Yeah, Blake has another question. He mentioned native threads are important today. Gerbil does not. Gambit does not support native threads. Does Gerbil?
That's wrong. Okay, there is SMP. It is wrong. It just doesn't work very lively yet. It's being worked on. So Mark Philly has written a fully SMP work stealing scheduler. Okay, but it has some bugs, and like when it works, it's magic. But eventually, it's gonna take fault. Once the bugs are ironed out, we're gonna have real end-to-end threads. Like with native threads. So I hope this does answer the question. It's not that far away, like
And
we're trying.
I do like Gambit's approach with mailboxes and things like that, because that
No,
does
yes,
remind me of like Erlang type of
yes,
thing, where you're
and we
sending
have
messages back and forth, the way you're supposed to do it. And you have a protocol between different threads, and you can send messages to each other.
yes, and
Really
we
powerful
have.
thing.
And we have like great libraries on top of that. We have, like a whole actor library, basically, which takes the Gambit primitives and adds a lot of nices on top of that. We can look a little bit in it if you want. But, like the point is, right now we have, like single core concurrency, great primitives, and the same primitives are going to work the same way once the SMP is stable. It's not that far away. It's coming. Maybe it takes a year. But, like in the not so distant future, we're going to have an amazing system.
Okay. By the way, Blake, if you want, you can actually just talk to the speaker directly, though. I'm happy to be your voice. But he after you mentioned that, he said, what about Lisp style macros?
Defined macro, you mean?
Do you mean like common Lisp style macros?
Yeah, you mean like defined macro?
Okay. Yeah, he said yes.
Okay, so you have to understand that Gerbil's macro system is fully hygienic. Okay, but like you can write defined syntax, and basically you can generate, like your macros with quasi-code and everything, but you need to pass context. We have really good facilities for working with syntax objects. So like, and it's very rare the need that we want to write, like a pure Lisp style macro, because we have like meta macros like def rule. Let me show you this one.
And also, he mentioned you don't always want hygiene. That's true. I think syntax case allows you to break.
Yes. Of course you can break. Sure it is. Just look at what like has does. Not only does it break hygiene, it introduces multi-identifiers that are going to go into, like from a freaking hash table. Here, we just use symbol to string, like to stringify the identifier, and then we're introducing this identifier, okay? And you can do that. You can totally do unhygienic macros. We did all over the place. Macros that introduce symbols. Okay, but like there is a nice thing.
More hygienic by default. That's the way you should.
Yes.
Syntax rules is basically hygienic practically always, unless you have it, because it's Turing complete theoretically.
Yes, and here's a very nice.
It's very difficult.
Yeah, here's a very nice mini syntax rule. Okay, so you just type def rule. Let's see if is it used in this file at all. I mean, we use it a lot. Okay, this is def rules. Def rules is basically defined syntax rules. It's very simple. I want to see if we have, like the symbol rule. Wait. All right.
Oh, we got another question on YouTube. So this is good. We're getting lots of cool questions here. How fast is Gerbil compared to other schemes?
It's as fast as Gambit, and sometimes even faster, because we have some custom code for things, which means it's pretty freaking fast, right? Like
Gambit, remember, it compiles natively.
Yes, of course.
Natively. It's one of the things I loved about Gambit. That's why I got into it for a long time. Was because of that. It's a really powerful system, and the fact that you're building basically, there's a whole lot of you have like, it's sort of like you have an engine, right? Like that's your Gambit, right? But if you just put a seat on top of a giant engine, right? It's not a great driving experience. This is about like
this is a whole frame, like this is a whole car,
nice and comfortable, have some shocks, some absorbers, etc. Some niceties, like for example, get out what you showed, right? That's built into, so you can just use it. You want to write your own command line tool. Okay, you got get opt already. It's part of Gerbil. Right?
Yep, that's the whole thing. It doesn't put just like a seat on top. It puts a whole car around this great engine, because like Gambit is the most badass scheme like imaginable. It's just great. It's Mark Phillips' life work, and it is great. And here is a very simple macro. You say def rule, define a set, and look what it does. Why do you need you don't really need like Lisp macros when you have this kind of facilities.
Yeah. I think for a lot of people, people like Lisp macro. I started with macros with Lisp macros, and the good thing about it is that you just like, let me just write the same form that I expect to see, right? And it does take a little bit of learning to go from there to like hygiene. However, it's not a add learning curve to learn.
Yeah, it's very simple. Like syntax case
You
has
know?
the same syntax pattern syntax as syntax
Yeah.
rules, and you can just do syntax case to the structure your syntax
Hmm.
object, and then you do a sharp quote. And you create your new syntax. Like, it's very easy. Like at first I was also a little bit put off with hygienic macros. I'm talking about like 20 years ago,
Hmm.
but once I got used, and at one point I read that great write up from some hacker, which is called syntax rule macros for the merely
Hmm.
eccentric. I don't know whether you've seen that, where he goes, and does all sort of crazy things with syntax rules, continuation passing style in macros, and then my eyes opened and I said, okay,
Hmm.
that's pretty fantastic.
So Jabberbase, Wizzy Wiggler, I think he was the one who asked about Gerbil compared to other schemes.
Yes. Okay. So when it comes to
Yeah, we'll get
standards,
to you and John in a second. But he said chicken scheme does too and is very slow. I think
yes, that's the big difference. Scheme chicken, in principle, it could be
Mhm,
great because it has a lot of libraries and stuff.
mhm,
But it's so slow, like that. It's a pity. We don't have performance problems. And if you want to really dig into and start optimizing things that by hand, going into unsafe mode and using unsafe operators. So, for example, a few years ago, we did a comparison with the word count problem, where you are giving, a file that contains words, and you want to get the counts for all the words that appear, and someone was doing language shootout and that, and I spent a few hours and I optimized the code and was going as fast as fast.
Okay, John Cowan, you raised your hand. You want to
Yeah, they
go for it?
they use that syntax transformer. It reads root piano until you don't.
You're a little low. Maybe
Oh,
speak a little. Okay, there you go.
Okay, hi John.
hi. The way to use the syntax transformer is read until you don't understand anymore,
Oh,
and then
okay, I
stop.
think
And then
Okay,
there you
so,
go.
so sorry, I missed something
Yeah,
in the
you
beginning.
gotta talk directly in the mic because I think it's very sensitive.
yeah, I don't know if I can get it.
Okay, if you
Can
want,
you
you
hear
can
me
type your
now?
question out too, and I'll just read it. If it does, if you're having mic issues.
Can you hear me
Uh,
now?
Oh,
yes, we can hear you. Great.
Okay, good. So the way to use the syntax transformer is read and then stop. And then
Oh man,
if you don't
sorry,
understand,
John. What happens is that when you say "Can you hear me?" it's great, and then afterwards it goes away. It's kind of funny.
oh dear.
Oh man, I don't know
All
what's
right,
going on.
I'll type it in the chat.
Okay, yeah, I'm sorry about that. I don't know
No, I would like to
what's
tell,
happening.
because I heard, this that's bad thing, okay,
Yeah,
this is the kind of introduction that gets me all fired up, because I love,
yeah.
having these discussions about what's
No,
bad and what's not
I
bad.
bet you this was going to be a good question because it's John.
I know,
But
that's John Cowan,
I yeah,
no, I have deep respect for John. So,
yeah. Anyways, also, MePlan asked the question: does Gerbil have a meta object protocol? What does it look like?
yes,
Are we going to
it
get to that?
does. It does. We're going to get to that. Yes.
Okay, we're getting to that MePlan. So, okay, and I think that's pretty much about it. Oh yeah, Hugh says that Hugh's excited about the turnout today. So, I am too because this is a great topic. This is
Okay,
like
so can we get to John's question? Do we have it?
not yet. You could type it on
I'm
the
typing.
chat.
Okay, we can hear
Yeah,
you
just type it.
perfectly when you're making these small utterances, but when you start actually asking the
Yeah,
question,
just so it goes slow. Anyways, let's continue. He's going to be typing, and I'll interrupt you.
okay,
So
okay,
please keep going.
all right. So let's
Oh,
look at
wait,
some.
hold on. He typed it in.
Okay,
The way to use syntax rules primer is to read it until you can't understand it anymore, and then stop because you have absorbed it all you can. Later on, come back and read it from the beginning. I completely vouch for that.
oh, you're talking
The
about the
syntax
syntax
rules
rule for.
primer is like my Bible.
Yes, I know.
I go back to that over and over again because chances are, if you're like, "Oh, how do I do this thing?" He wrote it in there, and you're like,
Yes,
"Oh,
I
that's
know,
what that's all about."
I know. So
But you
this is
have a problem.
yes, this is basically the primer I mentioned before for the merely extending.
Yeah.
I was so amazed when I first read it. And then, when I was hacking various versions of Gerbil,
Mhm.
then I got through the point that I said, okay, I'm going to make everything with syntax rules and continuous passing
Mhm.
style. Okay, and I made. And in the end, I got to the point that I had to introduce identifiers. And that's when I realized, okay, there is some limits, to what you can do with syntax rules. But otherwise, syntax rules is an amazing tool.
Yeah.
I generally prefer to write my macros with syntax rules, or even like the one arm def rule thing. And I only fall back to using def syntax and actual syntax case and the rest when I actually need to introduce identifiers, or if there is some complex processing that I want to do, in the input, because doing it with syntax rules can get really, let's say it obscures the actual code, the code,
Yeah, it does. You kind of have
yeah,
to go through a lot of circles just to be like at the end.
yeah,
Oh, I got
yeah,
it working.
yeah,
I mean, I know when I do make it work, even if it takes a lot, I'm pretty happy about it. But it's also like, yeah, you're really wrapping your head around where like, okay, if I could just break out of hygiene a little bit, it would have been a lot easier. But
yeah.
sometimes you just like the challenge.
Yeah, so in general, I don't like to break hygiene, but
Yeah.
it's very, very useful for a lot of magic things. It
Mhm.
can add, some great ergonomics to the language if you can break hygiene. You can try to do it selectively and with taste. So, and you can follow consistent patterns. So that the symbols that I'm generating are predictable, and it's what the user expects in general.
Mhm. Um, Anyways, and then just some joking on the chat, but I'll leave that for the chat here. So you guys can check us out on Meetup if you want to see that stuff in the future. But anyways, continue on.
Okay, so I was just gonna go through, the rest of the commands and then leave it up, open discussion, what you guys would like to explore. So one thing we already have is like looking at the object system. We're gonna do that. If guys, you wanna look into anything else, internal to Gerbil, how the whole thing works, just type it in the chat or ask a question and we can look at it. So, update is very simple. It opens the vault.
Oh,
Okay.
let me just. We have one more question about syntax rules.
Yes.
Jonathan Ruttenberg, by the way, I missed you in the socials. I don't know if you came back to New York, but I hope to see you again. But anyways, are the syntax rules lazy? They don't get written until you try to read them? Question mark. Does anybody know
No.
the answer to that? No, I
I
don't
will
think they
tell you
are.
the answer. They're not just not lazy. They're actually compiled.
Yeah.
We
Okay. Yeah.
have
So
compiled
thank God.
macros.
Yeah, so in that way, it's about as eager as it gets, but actually in a good way because you kind of want your
Yeah, and
syntax
if you don't
well
use them,
done
if you
before
don't
you
use
go.
them, you don't lose anything. So
Yeah,
basically,
yeah,
when
yeah,
you invoke the compiler, they just get compiled.
yeah, yeah. It just evaluates, and then that's what you're compiling. So
And not only
the
does it get
program before the
compiled,
program.
yes, and not only does it get compiled, I also have special optimizer passes for math syntax case and their
Hmm.
derivatives, so that basically it tries to, use common prefixes, it may do some reordering in maths, not in syntax case though, so that basically it eliminates a lot of duplicate code and makes the macros go fast.
Hmm. Okay, now I think we're done.
We can look at it if you want, because I think it's very, very interesting.
Hmm.
There we go, source. Okay, so this is a part of the internals of the compiler. Okay, so basically how this works is that when you write a syntax case, it generates a begin annotation form that has an annotation that tells the optimizer to apply some special optimization. Okay, so there are not that many here. It's basically for maths and for syntax case, because these are both very important. Okay, so if we look at optimize syntax case. Okay, so this is aware of the code that gets generated. Okay, so for example, this AST case thing, it's like syntax case, only doesn't try to decompose, and propagate marks and stuff, because the code is already fully expanded and its symbol is quoted syntax, so there are no marks to propagate. Okay, so it starts looking to the let values. Okay, And basically it applies a bunch of transformations by knowing what kind of code it expects to find. And like if you're gonna go down this rabbit hole, you're gonna see like all the optimizations that it's doing, like, which is it's pretty crazy. So maybe I should show you some expanded optimized code in order to figure out what it does. But like if you want to deep dive into that, that's the specific optimize for like syntax case, which is like this is one of the problem Racket has, is that I don't know whether they have fixed it, but back in the days when I was still working with Racket, macros were never compiled. I mean, they were interpreted as bytecode, and if you had like complex macros, things were starting to get real slow. Okay, so here we just compile the macros and it just work fast. Any questions on that? Do you want to try to, like, I forget how this code works. Like I wrote it so many years ago, but like I can figure it out.
I don't see any questions, so I guess continue on what you're doing.
Yeah. So okay, basically I want to show like a couple of interesting things. Basically to find the entry. So basically we have regular expressions. This is like the well-known regex library, which is integrated in the standard library. Okay, so what else do I want to show here? I guess that's pretty much it. Like feel free to read the code. Like if you start playing with it, and pairs are always welcome. If you want to help make it escape from Visual Sandbox and become generally usable, that would be great. But I'm a happy user so far. Okay, can I take a small break to drink some water and visit
Oh, absolutely.
the restroom? Okay, I'll be back in like 2 minutes.
Okay. Don't sweat. So far, so good. So yeah, if people have questions on the on YouTube, I'm going to relay them to the speaker. I thought the syntax debate was a lot of fun. And I found the Gerbil code really nice. I want to see some of the more of the. I want to see some of the other features that are featured on the website for Gerbil. I don't know if you guys took a look at that before the talk, but there was some interesting stuff. So, anyways, until then, luckily I already got mine. Anyone brought anything? Hogarth, my absolute favorite. Okay. Is there a channel on Libera for Gerbil? What's Libera? I'm not. Oh wait. Oh, that's the new Freenet, right? Yeah, Irk. Okay. Yeah, that's something we'll ask him when he gets back. Yeah, that's a good question actually. If he hangs out there, and I'll ask him more generally, where can the community go to ask questions, that kind of thing. Whoops, what was that? Okay, so someone's like riding out of here. Yeah, sorry, John, your sound's still pretty bad. I'm not sure why, but because you usually sound pretty good. There's a Discord for Gambit. Okay, I'm not a fan of the Discord. I don't know about you guys, but I was using Typist because I wanted to make some kind of, I thought it would be a lot easier than Emacs anyways. So I'm looking up questions on it. It's so hard to search. It's ridiculous. It's really it's where information goes. It goes in, but it doesn't really come out. I mean, it's fine for chatting generally, but if you're looking for what other people have talked about, funny. I don't know about you guys, but yeah. I'm going to ask that. Okay, John Cowan said yes. Yeah. Yeah, it's more. Yeah, it's more about the culture, anyways. Yeah, exactly. So okay, I better mention what the what is people. I'm reading this. I'm reading the chat here. Uh, yeah. So basically, they're talking about list macros. Can is it possible list? This is between the people here, but is it possible to list simple macro system to be done in Scheme? John answered yes, and he said syntax. He asked what implementation syntax case can do that for list macros. Anything that list macros can. I think the main issue is that, like, you know, in the Scheme culture, hygiene is important. So it's sort of like no one's really that interested in like making a common list macro system because people kind of, it's sort of like trying to different languages have different cultures where they accentuate certain things, and I think that's kind of like one of the
All right,
issues.
guys, I am back. Like the cat needed some pets.
Okay. That's good. Okay. Oh, we got some questions. Really good. We got really. This is a specific question, but I'm going to also ask it generally. But the question is there a channel on Libera for Gerbil? This is from Jerry. And more importantly,
Yeah.
where like for example, where for Gerbil? Like if you want to, what's the best place to hang out?
We use
Live
Gitter.
or like offline?
Yes, we use Gitter. We used to be on IRC until Freenode died, and then we just switched to Gitter. And Gitter is now on using Matrix, so it's pretty easy to get with us. Like if you just go to gitter.im, and you look for Gerbil Scheme, you're gonna find the community channel, and this is where the developers hang out. And people interested in Gerbil. Feel free to drop by. You can ask anything. We'll do our best to answer your questions. And in general, I mean, personally, I love having, people submitting PRs. It makes me feel good, even if it's just a small type of fix. Please, you're very welcome. Nobody's gonna tell you off, and we're gonna review the code, and we're gonna be nice. And if something is not as good as it could be, we're just gonna point out, and we're gonna work with you to fixing it. Yeah, please. We have a very open culture.
That's great.
And if you make a big whole bunch of PRs and you're a consistent contributor, I will be happy to give you commit access as well. There are 4 of us now that have commit rights in the Gerbil repo.
Cool. And let's see, anything else? Questions? There's more syntax case talk, but I'll leave that on the chat. And by the way, if you want to see the chat, you can click the it's the on the control panel on the bottom. It's the 4th button. We'll open the chat and polls for you.
Okay.
You might not be able to see it because you don't want to see your screen. But anyways.
Yeah. Okay.
I
Let's
forgot
see.
about that. Otherwise, we're going to go into an infinite loop and we'll never escape.
Yes, it's a loop. I'm gonna have to stop sharing, and I don't know whether I should do that. Okay.
But
So
I'll read it for you.
Yes, I'm going to say something about syntax case. Basically, I wrote my own implementation of syntax case because I wanted to cleanly bootstrap. And, there are existing high quality syntax case implementations, but they're not extensible. And they're usually, don't support modules. And, it's the module system is a pretty big part of Gerbil. So, I wrote my own implementation. And if you're gonna look at it and maybe you can port it, it should be portable to other schemes as well. So basically, it's under Gerbil Expander SDX case. Okay, so that's the syntax macro, and that's the other macro. Syntax case. And it's pretty expensive. You can tell it what identifier quality to use, how to unwrap, and how to wrap, and that's it basically.
Interesting. Cool. That's good to know. If you wanted to see how that works because syntax case is used in R6.
Yes. Oh my God! If you look at psyntax, it's almost impossible to understand that code.
Mhm.
It's psyntax and psyntax. So I wrote because I was bootstrapping and I didn't have a syntax case to bootstrap on. So here I think it was here, right? So I wrote this core syntax case macro, which is a very
Mhm.
simplified version of syntax case, and I use this inside the expander. And in the primitive expander that I wrote the bootstrap, I also implemented core syntax case. So the expander doesn't use syntax case, it uses this simplified form, which is also re-implemented again in terms of syntax case once you have bootstrapped. Okay,
Mhm.
and this is where the tail eats
Yeah.
the snake eats its tail. So yes, there is crazy recursion going on here.
Cool.
Yeah, this was mind blowing. At first I was thinking, okay, how do I make p syntax work? And I really didn't want to use to have to use syntax case in order to make syntax case work.
Mhm.
I don't know whether there are many implementations that actually work like that. Maybe Racket's implementation does also implement syntax case from scratch.
Mhm.
I don't have any bad words
Yeah.
to say about p syntax. It just wasn't suitable for my goals when I was bootstrapping Gerbil.
Mhm.
Okay, so I had to write my own.
Yeah. Um, yeah. Syntax case is good. I like it. Maybe you can go into R7 someday. I don't know
Yes,
what the
maybe.
standard is for that. If anyone's interested.
So yes, since you mentioned standards, yes, we support R7
Oh,
arrays.
John is the standard guy. He says that's coming.
No, 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 yes, we support R7 arrays. Most, at least the Red Edition. And as things are getting finalized, we're adding more support for that. So we usually
Okay.
take the standard code and customize it a bit for Gerbil so that certain things go faster.
Mm-hmm.
But yeah, so
Sorry,
you can.
basically you have an R7RS ingester for like R7RS modules because that's
Yes,
awesome.
we have a lang, so
I
you
do
can
like
say.
the package system in that. That was why That's why I fell in love with R6 because I have to admit I need the I like controlling the environment, right, and you can do that in these libraries. And R7 I think simplified it in some ways.
So
To make it a little easier.
you can do some crazy things in
Yeah.
Gerbil. First of all, you can change the prelude completely, and you can say the prelude that I'm using is not Gerbil core, but it's R7 array scheme, and then you
Oh,
just
okay.
get R7 arrays.
Oh,
But
cool. I didn't
we
know that.
also have support for the SARP lang form, and you can
Mhm.
specify a module, and you can completely change service syntax. Here, let me show
Yeah.
you something really cool, which is basically the protobuf parser. Okay.
Mhm.
So in protobuf, you can import protobuf files directly into Gerbil.
Mhm.
So all you have to do is just put a lang Gerbil in lang protobuf in top, and here is the grammar for passing protobufs. Okay,
Mhm.
and here is the actual. Hold on, that was the grammar. Yes, and here is the module that basically parses, takes the output of the parser. Let's see, read module. So here, by defining this read module body into a file that you use with sarplang, you basically can change the surface syntax completely.
Mhm.
Okay, and this allows us to parse protobufs. Okay, I have some. There is an example, for example, for instance, in the Gerbil lip2p module. There are some more lying around, but I think it's really cool.
Mhm.
Yeah. So if you check the tutorial on cons.io, we have some examples of how to write custom surface syntax. Okay, so I want to go a little bit on the object system because there was a question about that. Let's go back to scheme. Okay, so first of all, you can use the common devstruct. A doesn't have anything, but then you can start writing classes, which can extend structs, and they add xy, and you can then also do diamonds, so you can have
Sorry about
a,
that.
y, z, and then you can do def class D that basically mixes in B and C and adds W, and that just works. So you can do make D, and you can say X is X, Y is Y, Z is Z, and W is W, and this will just make you an object. And if you basically do, if you really want to look at the inside of an object, you can just do struct to list on SARP4, and you see here is a type descriptor, and this is what it has, and the elements are there. So basically the class system, the classes have slots, so they get remapped. This is what, so basically there is a hash table that maps, every instance of a class. There's a hash table internally.
Kill the live stream, that's for sure. Crazy.
Sorry guys, I was trying to define a generic method
Okay.
and not, like a class method. So if we use the squigglies around there, and then we can do foo on our object 4, and look, it just dispatches. And if you want to do traditional Lisp-like, common Lisp-like generics, we have import std generic, and then you use the other form of def method. Okay, so def generic fluid, and def method fluid with a D, and it's this thing, invokes the foo method on, I think, yes, let me, I'm forgetting the syntax here. Okay, let me, yes, I remember now. I think it's probably like this. Let's see. Yes, and now you can call fluid on number 4, and voila, you have generic methods as well. So to the person who asked about the object system, does this give you an outline? It's fairly elaborate. There is a meta object protocol, so basically you can work directly with type descriptors, and the type descriptor contains the methods that are for single dispatch. It also has metadata about the slots and the fields and everything you want to do. And if you're going to use with metadata, meta stuff on generic methods, you can also do that by utilizing the std generic facilities. So does this give you an overview about the object system?
I mean, it gives me a basic overview. I wanted to see if in the chat there is some questions. There's a couple of questions, but first I want to do the second one from me plan. Are you using generics frequently in your code?
Sometimes they're very useful. I use the single dispatch more though, because it's much simpler, and we have some optimizer support for what we call shield classes. So for example, once you have implemented, defined all your classes, etc., and you have the leaves that are actually pulling all the mix-ins, then you can say seal this class, and basically the optimizer is going to see that, and it's going to basically stop the search for methods by visiting all the file descriptors, but collapse everything in the leaf hash table, and it makes the dispatch really fast, which is very useful, and I use this a lot. And one of the things I want to add, I also want to add interfaces so that you can convert instances to satisfy an interface. And the comparison can be as fast. The conversion can be as fast as a hash table grab, and then all method invocations are gonna become all of one.
Mm-hmm.
So this in the works, a little bit like Go interfaces. So I know that Go is not very popular, in the Lisp community. But personally, I work professionally with Go a lot.
Mm-hmm.
And it does 80% of what you want from your programming language, but it does it really well. Okay, sometimes it's you write boilerplates, sometimes it knows you, but it's a very pragmatic language, and I like to take a lot of things from Go. So here's an example. If we go back to Passman, so let's look at our test tool. So inside Passman, you see that there is a unit test for the vault. So if you just do GX test, if you go in there and do GX test, it will run your tests.
Mm-hmm.
Okay, and this comes, from Go.
Yeah.
I am appalled at how people usually do it in, in other schemes. You have to write your custom scripts, and you have to stand on your head in order to make your test
Mm-hmm.
runs. Like here, you just give it a directory, or just
Yeah.
say run everything in the current directory, or you can do recurse, and it finds all the task
Mm-hmm.
test files, which basically have setup and cleanup functions, and export a bunch of test suites with our standard library. We have a standard Gerbil testing facility, which is basically, it uses tech as the main mechanism for doing assertions, which is an expanded form of the SRFI 78 tech. But it adds some it adds nice teas so that you can actually execute your tests.
Mm-hmm.
Okay, so here are some methods. For example, we have this display exception, so that we can do custom exception display. This is very important. Okay, so this is a method, and whenever an exception is raised and it gets caught, it checks to see whether the object has a display exception method, and then it invokes this one. Okay, and if you look at the family of checks, so here is how we do test suits. Test suits
Mm-hmm.
have a description, and they have test cases inside. Okay, and we do a bunch of checks. So
Okay.
let's go looking at
That's
an
pretty
actual test.
standard.
Yeah, let's look at an actual test. Let's look at the unit test here. Okay, so this is the vault test. Basically, it's a test suite that tests the vault functionality. Basic create update. So to call with temporary file to give you a temporary file name. So, and then basically you do a very simple check that you write and you read the vault, and then you check that it's empty. And then here is, how to check, all the stuff for CRUD. Okay, and it's important that it's easy to run your tests in the command line. I hate having to, stand on my head to run tests.
Mm-hmm. I do have an exception about what you said before about how maybe most listeners don't like Go, right? Here's the way I look at it, right? I think it's fantastic that people are using other languages. Even better, the whole beauty of Lisp is that you can create your own syntax. So if you see a great syntax thing that Go does that makes it easy, do it in Lisp, right?
Yeah, I know.
Just
I
steal it
know.
all, right? I mean,
Yeah,
it's fantastic. Oh, it does channels really well. Let's make a channeling.
we have channels. We actually, yeah, we actually have channels. So yeah, if you look in the standard library, so if you go MISC channel, here is a channel implementation.
Mm-hmm. There you go.
Yeah,
Right.
So I think Go is a
There you
very
go.
Yep. No. If it was in my hands, I would be writing all my code in Gerbil. But I have professional responsibilities to work within a team.
We
So
all work in lots of different languages.
yes, I know.
It's something great. You're like, you know what? I really love this. This makes my problem so much easier. You can feel it. Now they can't do it because the syntax is run by the
Stalinist committee. The Stalinist committee.
It's we the people that make our own syntax.
Yes, I know. Extending the scope of syntactic abstraction is basically the essence of Lisp. And you see what people are doing in other languages and say, okay, we can do that. But yeah, there are pragmatics involved. Go gets a lot of things right, and it has inspired me in a lot of things. So, for example, the static binaries. So, that's the most beloved feature of Go, that it quickly compiles and generates a static bin you can drop on your server. And I had to have this feature in Gerbil. Okay, and yes, this is it's a killer.
It's great.
Yeah, it's a killer. I don't do any GUI programming personally. If I want to do GUI programming, I'll just do it in the browser. And we have an embedded HTTPD, inside the Gerbil standard library, so that you can write your, front end. So, for example, Juicy is using professionally here for building websites and web applications for clients. It works pretty well. And I can't wait for SMP. Like I'm dying to get the SMP stuff working.
Mhm. Cool. That's great. So it has channels. That's awesome.
Yeah, so here's another thing. So the struct constructors, right? If you define the special init method in the constructor, so when you say make channel or you use like the macro version of just channel, it's going to invoke the constructor. And the cool thing is that the optimizer, the optimizer in the Gerbil compiler is aware of this. And if it sees you invoking, like a constructor, making a struct, and it has visibility inside the struct with optimizations, which is basically pretty much all the case if you're compiling with optimizations, then it's going to dispatch directly into the constructor. So it's going to avoid, like the hash table lookup, like all the periodic arguments, like marshalling. It's just going to go straight into the constructor. And we have other similar optimizations. For example, case lambdas, like are directly dispatched. Opt lambdas and keyword lambdas are directly dispatched, like by the optimizer when you're making a direct call. And like we have something that like I always thought that all the schemes should have. We have arity taking in the compiler. So if you're making direct calls, it's going to take the arity and it's going to bomb and says an error if you're passing the wrong number of arguments, which saves countless hours of debugging, like when it comes to scheme. So, any further questions? Anything else you would like to explore now that you have me here?
Sorry, we
I
got
mean,
more questions actually. Okay. Let's see. We already asked about the meta object protocol. Let's see. Oh, MePlan asked before earlier. I said his second question. No one asked the first one. How do you define grammars?
oh yes, we have like a DSL, a standard module. So basically, you don't have to use it if you don't want to, but it's pretty good. So okay, let's look at some grammars. Let's go back and look at the protobuf grammar. So that's how we define grammars. So basically, we say, oh, here's an example of sublang. So basically, it's a custom language that says use the parser grammar, okay, and generate a parser which is called parse protobuf and use a lexer called lex protobuf, and you basically write it in GLR, generalized recursive, basically. So that's how you typically define grammars. And the lexer is down here. Now it's pretty simple. Yeah, so this is a great example. If you want to look at the grammar definition, just look at the protobuf grammar. Any follow-up questions on that?
I'm okay. Let me. Sorry, I was interrupted there for a second. Okay. Oh yeah, MePlan. Let me know if you have any other questions about that. We also have Jabber based on YouTube. He's asking, how is the GC in Gerbil? I see a lot of. I see a lot of stalls working on large data sets with Guile and others. I can't read that.
Yeah, okay. So there are a couple of things with the GC. So, like Mark Phillick has spent a lot of effort in making the GC really efficient. Okay, it's, it has several classes of allocation. So there is the default, which is the semi-space. Well, it's not exactly semi-space. He's using small arenas, basically, which is the bump allocator for all the stuff. And then, it has mark and sweep for foreign objects. And you can make the GC run in parallel in multiple threads. And generally, I haven't noticed any problems with the garbage collector. Maybe with large data sets it will have problems, but it's generally a lot more efficient than most of the other lists. So the only way to get better is if you start doing some generational concurrent tricks, like Java is doing with the G1 garbage collector. But I don't know how complicated it's going to be to do this. So in general, the garbage collector is good. I mean, personally, I haven't observed any poses that got on my nerves. And we're talking about like a 20-year usage, and I have worked with modestly sized data sets, and it works just fine. But here's the other advantage of Gerbil and Gambit in general. If you really want to work with giant data sets that are structured, you can just map it, and and treat the map region as a vector and start doing U8 vector refs inside there. So you can do that.
That's good to know. Yeah. Gambit has a pretty good FFI. Now let me ask you this: does Gerbil put any like Chrome on top of Gambit's FFI?
Yeah, we define like a few macros. Let's look at an example. Let's look at a hairy example of FFI, libcrypto. So here we have this begin FFI form that basically defines all the symbols that are going to be defined and exported, so you don't have to do it manually. We have macros like define const. They're the basics like define type, but if you look, actually, let's use the tag. So here, so there is a bunch of macros. So we do have some sugar on top, yes. For common things, so for definitions of structs, and all these things. Yeah, there are a lot of facilities, and if you actually find yourself, so for example, this is a very common thing that you have to do, like the FFI freeze, or where you get a pointer from the FFI and you want to define a custom free function. Basically, usually you just call free. Okay, there is an implementation for that, and when you go into, for example, libcrypto, and you make objects, do we use FFI free in here? We probably do. Oh yeah, actually, this is not a good example because SSL has its own cleanups. But let's look at some of the operating system stuff. Okay. Yeah, let's look at sockets. Actually, let me grab here. There are uses for it.
In the meantime, while you're doing that, Alexander Shendi.
Oh yeah.
Hi. You know Alexander? Anyways, hello back.
Hello back. Yeah. So here, so we use this FFI freeze tab because it's very useful. So yes, we add some sugar on top of Gambit's FFI, which is the common macros. And if you find yourself writing, like FFI code, and you come up with a cool macro, you can just make a PR and add it to the begin FFI form.
There you go.
So,
that's awesome. Yeah, this is like the I would say like probably the super feature of Gambit, and then adding on top of and Gerbil, because Gerbil adds a lot of sugar and spices to make a beautiful dish, right? But basically, it's all about the compiling down and running as a binary. That's like a huge advantage that Gambit, and it's fairly fast too.
Yeah, no, so
it's a really good scheme if you haven't used it, right? I think a lot of the things is like, oh well, I'll use Racket because it has all this great stuff.
First of all, the Racket,
you have Gerbil now.
Yes, so think about it.
You know.
Yeah, so like Racket inspired me to make Gerbil, because Racket has really good metaprogramming facilities. So I wanted to have this, and I want to have my binaries, and I want to have like my end safety, and I didn't want to have my hand holding. I mean, no offense to Racket, it's a great language, but it does a lot of hand holding. For example, what's up with not having set car and set cooder? Like what's up with that? Yeah, it's my pair. I want to do whatever the hell I want with it, right? Including modifying it. Yeah. Okay, so then you have the M car thing, and then you can do for each on an M car because it's not, like a pair. What's up with that? Anyway, like I don't want to get into a language law where I have deep respect about Racket.
A little chiding among the schemes. I mean,
yeah, no, look.
Like I said, you found a lot of things you liked about Racket, right? But it's also
I'm in the credits file. I'm in the credits file. I'm in the credits file of Racket. Like I use Racket very heavily. Like I deeply appreciate it, but I want to make a better language.
Of course.
That has like an underlying
And
foundation. And this
is
is
kind
the
of, yeah. Go. I'm sorry to interrupt, but it's kind of
the-
like a feature and a bug in Lisp is that it's always like, oh, you know what? Because of the fact that you can kind of make any library you want. Oh, well, I like this object system, but this one little thing really annoys me. Well, then you go into a rabbit hole like, I want to make a version of that myself that gets rid of that annoyance.
Here's the funny thing.
So many times.
So
it's like,
here's
it's 90% there, but I wanted to change a few things. So you're literally like, okay, let me take their stuff and start changing it around a little bit.
Here's the funny thing. So after Gerbil, I started working on Gerbil. Like actually Racket switched to the same model, and they rewrote Racket, like in Scheme in Racket, and they're using C now. So basically, it's a competition between C and Gambit underneath, and Gerbil and Racket, like in top. So they have the same model. It used to be, like that. Racket had a humongous C code base, like several hundred thousands of handwritten C code. And they did a lot of work. I mean, Matt is, he's a great hacker, and like she rewrote the whole thing basically in Scheme, and now it's the same model. So here's a big difference. Like Racket modules are multiple instantiation. Gerbil modules are single instantiation, because I want to have my damn side effects. I want to have state. I don't want to have this isolation, but they have different goals. My goal is to build a pragmatic programming language. Well, like in Racket, they have to basically build this language as a didactic tool, and they have students, and they want isolation, and they want to be able to run like student code in their servers without crashing. So they're different. They have different design goals. So there is space for everything.
And then this is the power of Lisp, and in your case you had a really big bug cage, so that's why you did so much of this work. Now a lot of other people can benefit from it.
Yeah. I mean, it was really bugging me that I couldn't make binaries, like back in the day. Like I had to bring with me the whole Titanic, like their definition of standalone binaries to embed, the whole, bytecode interpreter, and actually embed the bytecode and interpret this at runtime. That's not going to cut it.
Okay, let's see if there's any other questions here. Otherwise, you can continue talking as long as you want, but I don't see any other questions on YouTube. Jonathan, by the way, is waiting for Dwarvis Racket. So.
Okay, he's coming after me with a racket. Yes. So I want to reiterate, I have nothing but respect for Racket. I think it's a great language, and it inspired me to write Gerbil. We just have different design goals. Yeah.
This is the beauty of Lisp. It's the beauty and the curse. You can be as opinionated as you want if you want to do the work, The curse is that you just end up going through rabbit holes sometimes. Just like, oh, finally, it's not the way I always wanted it to be. But that's, for your, the great thing is you can make the tools that you need to accomplish the jobs that you want to do. And you don't find adequate tools. I mean, if they're closed, you can change them. And if and that's open source, right? And if you see something in some other language, say, oh, well, I really like that idea, you can just import it a lot of times, it's fantastic. This is like the exemplar, I would say, of this whole mentality. Right? That's what we're experiencing.
Yeah, this is, people, a lot of people are put off by the parentheses, and they don't realize that parentheses are a feature, not a bug. It's what allows you to write macros. And this is the alien power of Lisp, like the fact that code is data, and you can do everything you like within the language. And, if you have, in the end, complex programs, highly complex programs reduced to a 10-line main, and a DSL for implementing the details, right? That's the whole model.
Yeah. So, anyways, anyone have any other questions? Do you want to talk about any other features that you'd like to show us?
I wanted to give a little bit of an overview of the compiler itself, which is pretty cool. Actually, let's do something else. I want to show you a little bit of the structure Gerbil itself. Okay, I like to name my buffers so that I can switch to them quickly. Okay, Control plus. Okay, so here's the bootstrap. So this is the precompiled bootstrap, right? So here is the core prelude as it is compiled. Everything, the expander is in here, the compiler is in here, and this is what we call the Gambit prelude, which is basically extra symbols of Gambit that are not included in the default prelude. Okay, so if you look at the code, okay, this doesn't actually do anything particularly interesting. So, oh yes, here, let's look at the section. So you see, this is like scheme code. You can read the bootstrap. You know, we're not doing anything nasty. You can actually it's very readable. So this solves a problem with the binary bootstraps, because personally I don't quite like binary bootstraps unless I fully trust the person who is doing them, and his name is not Ken Thompson. So like I think that this is a great feature that you can actually read, like the bootstrap.
Yeah, that's great.
Yeah, and so if we go back into Gerbil, where we are. Okay, so here's a little bit of how the whole thing. So this is the Gerbil implementation in a sense, or the starter library. So it has a very small runtime. Okay, so this is what we call Gambit zero, Gambit zero. Basically, it provides like a bunch of functions that are necessary to implement the expander and the compiler and the prelude. So here is the mob, since we asked about it. So here's a type descriptor. So it's an extended Gambit type descriptor. So basically, we make a structure that's type, but its length is bigger. And here it includes the mixins, which are the classes that are getting mixed in, the fields, the property list, the constructor method, slots, and the methods has table. Okay, so and this is the whole mob. So basically, you can do stuff outside the macros
Yeah.
directly, and you can inspect like everything. We have like things like make extract field accessor. Okay, and here's the important thing: when like the compiler, the optimizer specifically sees a my extract field accessor, it optimizes applications of this accessor to bypass the lambda. So
Yeah.
this is a
Oh,
direct
nice.
structure rev, which basically allows you to, when you do optimizations, like it can become, this is the structure ref, this is the save variant, but if you define declare unsafe, then it's going to bypass like the text, the type text. So this may sound like a heresy or maybe completely unsafe, but I am of the opinion is once a program has been sufficiently debugged and like the internal struct access are all verified, then you're free to go unchecked and reap the speed, the performance improvement. Okay, maybe this is
That's
controversial,
awesome.
but I think like the lifetime of a program. Okay, at first you do everything safe because you're hacking, you don't go crashes right and left. But as modules are getting more and more, crystallized and more debugged, you have your tests. Like you have good test coverage. You feel confident about going unsafe, then you just do it. Just declare unsafe on the module. So I'm going to show you, like an example of highly optimized code, which is handwritten. And this is currently the fastest string to UDF converter that exists, like in Scheme. Okay, so, like in the older, Craven benchmarks, this was the fastest string to UDF-8. Okay, and if you look at it, like this is very low level unsafe code, but it's very carefully written, very carefully debugged.
Mm-hmm.
Okay, and it's extremely fast. Like, and you can do this in Gerbil. Like, and this is because we're reaping the power of Gambit, and this is the thing I love most about the Gambit. Everything is accessible. Like all the
Yeah.
internals are accessible.
I've
Like,
noticed that myself when I was hacking in Gambit back.
yeah,
It was
this
a
is
long time ago, but anyways, yeah, Gambit. You can get into the code, and it's like you can basically figure out exactly how Gambit does something, like for example structures or whatever, and then you can just implement your own stuff on top of it.
precisely.
If you
This
just
is what
want to
I
go
did.
down to that level, like the same level that Mark has, you have. if you really want to go down there, and you can do whatever you want. I mean, it's very hackable. Gambit's a very hackable scheme.
No, Gambit is hacker's delight. Like absolutely. I mean, Mark is totally a hacker. Like he's a very smart guy, and he's
Oh yeah, definitely.
extremely competent programmer. One of the best programmers in the planet, in my opinion. And building on his life's work. It's just the right thing to do.
Yeah. Oh yeah, and then you get all advantages of his optimizations. You can say, oh, you know what? I don't like the well, like for example, for me in my case, back a long time ago, I love Gambit. I was like, but I want to have the R6 modules on there, right? So I wrote, an R6 compiler, basically kind of like what you're doing, but it was just with just standard R6 with the R6 libraries, and the structures, for example, like implementing the standard for the record syntax, right?
You can
right on top of his structure,
Yep.
which meant that like anything that was in the Gambit world would work in the R6 world, or vice versa.
That's
So they had,
exactly
like, a Gambit library
yeah.
to communicate.
They
didn't really know about R6. They could still communicate with each other.
That's exactly what Gerbil does. Like the structures. We just do.
Exactly, yeah.
Yeah, it's just an extended type, like the type object. Okay. And, this allows us to use like the low level forms that the Gambit compiler is optimizing, like structure ref, and structure set. And, it's magic, having access to all this power. Sometimes it feels like power overwhelming. If you remember, like the old StarCraft, when the Archon was selected, and it was like power overwhelming. But yes, this is the good power.
Mm-hmm.
And obviously, you can royally shoot yourself in the foot, and you can segfold, really wildly. But that's okay. I like the fact that I can read arbitrary memory by just doing, sharp U8 vector ref, some number, which is, like a pointer, in effect. And read, steps. This allows you to disassemble a function, for example. You can read a function with U8 vector ref, a bunch of, and you can see the instructions in the function.
Mm-hmm.
There are all sorts of cool things you can do. I know. I mean, probably John Cowan's hair is raising because I know he's really big in in safety. But
Mm-hmm.
you can have both things. You can write perfectly safe Gerbil code if you want.
Mm-hmm. Okay, well, let me see if there's anything else. If you want to talk about another particular subject, we can do that, or we can just stop the stream now if you want.
Okay, let me talk a little bit about the compiler.
Oh yeah, definitely. Oh yeah, I forgot about that. Yeah, definitely do that.
Yeah. So first of all, let's look at GXC. Where is it? Oh yes. Where did I hide? Where did I hide it? Let's find it. Tools, Gerbil. Yes. Oh, here it is. GXC. So GXC is just a Gerbil script, right? But everything is in the compiler package, and it's all compiled, and optimized and everything. But this also means that you can very easily use the Gerbil compiler inside your own programs if you wanna invoke the if you wanna basically extend or make a different script, because this is pretty basic. Okay, so if you look at so here's the neat thing about having the compiler as a package, because then you can make things like the make library, which is what is used, so we have make. It used to invoke the compiler directly, but I think that oh yes, it still invokes the compiler directly. Great. Because Faray made a lot of changes there, and I don't, remember what is. Oh, here it is. We invoke compiled file. This is how we actually compile through make.
There you go.
Okay, and if we go there, okay. So basically, we just import the compiler driver, and we export this. And needless to say, if you want, you can import individual compiler files. So because the compiler is going to Bootstrap, this is one of the few places where we have to do string includes instead of the relative path. But this is because the compiler is special in the sense that it needs to be compiled for Bootstrap. That's the only reason. And basically, if you were doing, like through this index with a column, I picked it because it says go through the load path, basically. Okay, and if you're going through the load path for the compiler, you wouldn't be able to modify the compiler cleanly. Okay, so that's why it has string includes. So let's look at the compiled file. Okay, it takes a bunch of options, sets a bunch of parameters for the rest of the compiler, and it goes to compile top module. Okay, so the first thing we do is basically it takes an expanded context here. We have already expanded it. It calls optimize, which is also quite interesting. You can see all the paths, like in the optimizer. Okay. So we use an intermediate file, which is, like just another scheme module, a Gerbil module that basically is used by the compiler. We call it the SSXI, which means scheme source expanded interface, which basically has things for the optimizer. Okay, and optimize source. Okay, so first we collect mutators to see what is mutable or not, and if something is not mutable, we can do some more optimizations. We collect methods so that we can do all the method optimizations. We collect type info about the type definitions, okay, so that we can generate method specializers. Lift top lambdas, which basically when you have a case lambda, we lift, like the individual cases so they can be directly dispatched, we do optimize annotations and we optimize the calls. So, this is the entry point if you want to look at what Gerbil Optimizer is doing. So, I'm giving you these tours because I reckon there are people who are interested in the internals. And, this is the starting point for actually looking at optimizations. So we have this macro that basically has grep. There we go. Oh, it's here. Yeah. Okay. So this is how it's used. You specify, like the fully expanded forms that you want to operate on, and you give it, like a transformation. So basically, we have a generic compiled path that takes, like a syntax tree, and it goes through it, and it applies all the transformers that are applicable in there. Okay, so like there's a bunch of base methods, and all the optimizations are there. So for example, here is apply collect bindings, right? So let's see what bindings. So here, okay, so if it's an identifier in the binding, in the head, we just add it, to the module binding. So this is the binding table, like in the environment of the compiler. There are no globals. Everything is done through parameters. Okay, so this is in general should be very readable code. I think, I like this code. I find it hard to improve. Maybe it's a little under documented because I was furiously hacking. And
I think this whole def compile thing is really cool. I definitely want to. I gotta review this video again to actually watch this one. That was something I wasn't expecting.
Yeah, well, there's a lot of macroology. That's why I wrote Gerbil, for the macros. So here's interesting thing. So for every module, it generates, a bunch of low-level Gambit modules. Okay, there is the runtime code, which is the code that gets executed on the runtime, and we support the full syntactic tower. So for every phase, we generate, phased modules. And you might have to break it to multiple pieces if there are, for example, inner modules. You do stuff like begin syntax and evaluating code. Okay, and basically, we generate a bunch of files. So if we go back into the bootstrap, so that's a good example of generated code. Not here. It's here. All right. So let's look at all this code that got generated from Prelude, and we're going to look at the Prelude next because I think it's interesting. Oh yes, like that. So here is one of the parts, okay, and here is the most interesting part. This is an inner module that says, "Hey, here is syntax case. Here is syntax and syntax case," and we just use the macro from the expander, and that gives us another thing. So predictable names of the runtime symbols. One of the things that I absolutely hate in C is that you have no fucking clues, excuse my friends, about what the name of the symbol is at the runtime. Here, okay, in general, it comes from the package that you specify in the Gerbil packaging, and it's constructed by the module path name, and that's the namespace separator. But you can also do it manually, and you can say namespace, what namespace you're going to use. So, for example, if we go back to here it goes. You see that we have here namespace GX, okay, and all the symbols are going to be in the GX namespace, which means that we can actually find them, easily where we need them.
Yeah.
Which is very important.
Okay? Oh, I agree. Actually, the thing is, it's sort of like you get annoyed when you see symbols like pound, like G123, which, by the way, is even stronger password than your 123 password. So that's the
yes, I know.
you should actually be using. 123 is a weak password, so use the pound G123. But because that you'll never figure out what the hell that is. But anyways.
Yeah. Okay, I want to also show you the prelude. This is the language that we get, if you do nothing. That's the Gerbil lang. Okay, so it also shows some more things about the module system. For example, nested modules, which is important. Like how imports and exports work. You can specify, like the phase differential, where to export stuff.
Yeah.
Okay, so R5RS runtime. So this is all the R5RS procedures. We have those. Okay, this is the host runtime, which is basically all the stuff that is defined inside GX GAMC 0. Oh, I should also add that like this 1 plus, 1 minus, FX plus, minus, etc., are optimized by the compilers so that you don't have to go through a cross module call. It's directly inline. Okay.
That's cool.
Yeah. And here is the expander runtime. This is what you get, at when you're inside, the phase one, basically inside the body of a defined syntax, or if you do a begin syntax. This is, the public safe expander runtime. If you want, you can just import the expander. If you want to do some magic, you should probably import the expander, but you have to be, a little careful with what you use. These functions are guaranteed to be safe, but oftentimes for performance reasons, I compile the expander with declare not safe, and this, cut the load time, of the interpreter, by a factor of 3. So this is very important. So let me give you an example. So look, it takes 20 milliseconds. Okay, that's reasonably fast. Okay, Gambit is even faster because it doesn't have to load the expander. But compare this to Racket. Racket can take hundreds of milliseconds to load. Yeah, so when I started, back in the day, okay, my old laptop was, half as fast as that, but it was taking some 700 milliseconds to load. I optimized, and now it's taking like 20 milliseconds, which is acceptable. It's fast enough for the interpreter.
Yeah.
Yeah. So if we look more, into the prelude, so you'll see that everything is defined, in itself, right? So everything is there. There are some core forms inside the expander, okay, but everything is defined in here. And it's very easy to change because it builds progressively, and it's also instructive on how to build, core scheme forms. Okay, so some people might be interested in digging into that. Okay, the last thing I want to show is I want to show some magic with the expanders. So if you go into tools and let's look at GX test, for example, the test runner, okay, which I think is a very interesting program. So here's what it is. We give it a bunch of arguments, a possible filter for what test suits to run, and a verbosity flag. So the first thing to do is to load the expander, because by default, binaries don't load the expander because you want them to start fast. You don't want to get the whole tsunami. But if you want to use the expander, you have to load it. Okay, so that means that if you're compiling a binary and you want to use a val, then you should load the expander. Okay, that's like one thing to know. Okay, so I want to show the collect files prepare test suits. This is so basically. Okay, so we import the module just like that. Okay, we just call import module, which is a function from the expander, and we tell it to basically not reload and to eval it. Okay, and if there is an error there, we store the error, return false, we print the error, in the command line, and we also keep track of the error so that we can basically fail the test if some module failed to load. Okay, maybe everything runs fine, but all the new tests that you wrote, basically they don't load because you have a syntax error somewhere, and then it could be completely inappropriate to run GX test and it says it's okay when your new test module actually didn't run, right? Okay, so here is using the expander API. So we take the exports, the exported symbols. Okay, we check if it's a runtime export and if it's a dust test, which means it's expected to be a test suite. Okay, and we eval it. Here it is. So basically, we resolve to the real name, which is the runtime name. We just call eval.
Cool.
Yeah, eval is one of those features of Scheme that at first you said, yeah, maybe I don't need it. Then the next day you say, oh, I love it, I'm going to do eval everywhere, and then you realize it doesn't work that way. And in the end you realize that eval is really magic, and there are certain uses that you just can't do
Don't use
without
too much
eval.
magic.
Yeah. There is you have to use it with taste, heartfully. Okay, so basically this is collects the test suits, and here is the really neat feature, because if you say export and you export a bunch of symbols, then the order is going to be preserved, and that means if you want to order your tests, which is something we had a very lengthy conversation with Farai about, is that you can do it through the export order. There's no need to do crazy things like having a form to do dependencies, right? Okay, and it freezes up the setup and cleanup function. And let's see here, and here is the runner. Okay, so for all the suits that we collected, they have a file, setup and clean up functions optional and suits, and we have a filter. So if everything is filtered out of this test file, then we shouldn't run setup and clean up. It's not useful. So otherwise, we say, okay, we have setup, we run the setup function, then we run all the suits, etc., and in the end, we display the result from the test framework, and if it's not okay, then what's the meaning of life? You have a bug, right? Exit 42.
That was funny.
All right. So basically, these are the things that I want to show. Are there any more questions?
We got one more question. We got a couple more questions that are coming in. Okay. Well, first of all, Jabber Basis wanted to add like saffron on a paella.
What? What was that? Come again? Is it written in Greek?
I think that's like I don't know if that's Greek.
Okay, sorry, I didn't understand this.
Yeah, I didn't understand it either. I'm not sure what a paella is. I think I heard of it before, but I don't know. Anyways, but we got one final question, right? This is the question of all questions, right? any projects using Gerbil in production?
Yes, there are. Okay, as I said, like there are people who are doing web applications for paying
Yeah.
customers, like with Gerbil. Like there are people doing DevOps with Gerbil. Like there is the Glow language framework that Faray is
Yeah.
working on. Like a mutual
Uh-huh.
knowledge system, and this is very
He's
much
a
for the
big
action.
Gerbil guy.
Yeah, it's written in Gerbil, and like it's
Yeah.
a smart contract compiler. Like in libraries, and like a whole language for writing smart contracts. And
Mhm.
this is important because like this is critical code. If you do a mistake, like in a smart contract, you can lose
Oh, yeah,
billions
yeah.
of dollars.
Exactly.
Yeah,
That's not a good.
yeah. So
You're not gonna have a good day.
yes, it's going to be ruined. So yes, Turbo is used in production, and we would like to increase this, like by
Mhm.
increasing the user base. So
Mhm.
uh, so like the last couple of years, I was a little bit absent because like I was stressed with work and having too much stuff to do. It was too draining.
Yeah.
But like after 6 years, I left PL. So and I moved into the Ethereum ecosystem, working on a really cool project. But it's also much more relaxed, which means that I get my evenings back, and I'm back to
Mhm.
hacking Gerbil every
That's
evening.
awesome. Which would just
Yeah.
help your brain better during the day.
Oh yes, of course,
You know. Yeah.
spend a couple of hours at night, hacking Gerbil, and then play some poker on the PlayStation, play money, play poker club. Okay, so I don't have to go broke, and then go to sleep. And the next day you wake up relaxed, and and you go to do your work.
Mhm. Okay, well, we had 2 hours on the live stream, minus some of the interruptions, but due to the server going down. But I think this is a great way to end it. I want to thank you for giving us this tour. Actually, this is going to be a gold mine in the future for anyone who's interested in Gerbil. You can review this
Absolutely,
video, and you can see
yeah.
you got the documentation live, right, as a place to get started, right? So yeah, I want to thank you. I want to give a special thanks to Zoe Breiterman for introducing us and getting you over to speak at LispNYC. And of course, I want to thank the viewers and the participants in the conference for all the amazing questions and just checking it out. I want to, I want, let's put my image on there. Oh, it's not coming up. Anyways, I want to have, whoops.
Okay, how do I start? All right, I got it.
There you go. There you go.
Yeah, I managed to stop. I would like to read the chat.
I want to remind our viewers on YouTube, right? If you like this type of content, you can subscribe. We got a whole bunch of other amazing videos. And of course, you should like the video so that way other hackers are going to be like, oh, well, you're a hacker because you like to watch a lot of cool hacker YouTube videos. Other ones are going to get recommended on that. And also you can check us out on lisp.nyc/contact to contact the whole membership. There's a whole bunch of ways: Twitter, Facebook, etc. And I think with that, we're gonna close those parentheses, right? Meanwhile, we're gonna stay for a little debriefing, but for the rest of us, we're signing out. Thank you very much.
Oh, and before we go, I know you thanked me, but Francois Rene Rideau was the one who introduced me. So
okay.
I wanted to give him a shout
Extra
out.
thanks to him too.
Of course.
Yeah, seasoned member of LispNYC. Thank God we have a community like this to bring. And by the way, this is just tells you how we actually depend on the community to bring other people that we may not notice, to bring them in. Say, you should check out this guy or check out that guy. So you can do that by either if you're interested in speaking, speak at lispnyc.org, or you can just write, hey, why don't you ask this guy to speak? Because you'd be surprised how often when I get those things, how it happens. But anyways, okay, now it's official. We're starting out on the live stream. We're sticking around here for a little after party. Thank you guys very much.
Great presentation.
Thank you, guys. I had a lot of fun, doing this, and I'm really happy at the amount of interest